Hello everyone. Today we're going to talk about vertical stretch. So in previous lessons, we looked at reflections, horizontal and vertical. So really we started off with the form y is equal to f of x, pardon me for the writing, and we changed that, or we transformed that so it might have the form y is equal to a f of b of x. Now I know that I'm writing this a little bit different than before, but a and b, where a affects the vertical reflection, in other words, a reflection about the x-axis, and b is the horizontal reflection, or reflection about the y-axis, right? So if a is negative, it's a reflection. If b is negative, it's a reflection. So today we're going to work with a and b in a different capacity. And we're going to talk about vertical and horizontal stretch. So again, you may want to write this down. A will have to deal with the vertical stretch in this example, and B will have to deal with the horizontal. So let's just start off with this example. Given the graph, y is equal to f of x, which is right here, we're going to denote the domain and range. So very quickly, I would like you to do the domain and range. Hit pause and write it down. What I'm getting here is the domain is -2, 4, inclusive of the endpoints, and the range is square bracket 0, 3 square bracket. Right? Square bracket means that we include the endpoint. So let's move on to the example. We are going to sketch the graphs of the following transformed graphs. We're going to write the mapping notation in the points of x, y. We're going to describe in words what is the transformation and note the domain and range of the transformed functions. So let's look at g of x first. I'm going to have writing in blue for g of x. So really, y is equal to f of x. Now we're transforming it into y is equal to 2f of x. In other words here, a is equal to 2. Because a is the number in front of the f. So in words, this means vertically stretch. Now you can horizontally stretch or vertically, so it's really important to say vertically stretch by a factor of 2. Now, so that's the description of the words in transformation, or the transformation of words. Now let's go on to the mapping notation. So f of x has point x, y. We move that, or we will transform that. How does this change the graph? Well, really, we multiply the y values by 2. So let me visit the graph here and put this mapping notation here, the point notation, to use. -2, 3 becomes -2, 6. 0, 0, well, we're multiplying the y values by 2. Since the y value of this point is 0, remains at 0. 2, 1 becomes 0.22. 4, 1 becomes 0.42. So here we have 4 very important points on the graph. So let us connect those dots. Please do that. So when I connect those dots, oh, there we are. Nice straight line. Now I go up to this line, and there's my function. So this is my function. I'm going to write in blue, y is equal to 2f of x. Right. Let's go on to the next example. Here, h of x is equal to 1/2 f of x. So now here, we're still going to be transforming this black because the h of x is really a transformation of the original function. So I get a is equal to 1/2 here. What we say is we vertically stretch this by a factor of 1/2. So we start off with points x comma y. Now how does this change this? Now a is really affects only the y's, so the x's stay the same and the y's become 1/2 y. Or another way of saying this, right, we can multiply the y values by 1/2, or simply we can divide the y values by 2. Those are the same process. So let's do that to the graph. So this was point -2, 3, becomes -2, 3/2, right? 3 divided by 2 is 3/2, or 1.5. Similarly, I can do that to this point, multiply the y value by 1/2. 0 times 1/2 is 0. 1 times 1/2 is 1/2 and 1/2. So now, there we have it. Okay, you may want to make that line a little bit straighter. These things really do matter in pre-calculus, making your lines a little bit straighter. So let's get rid of that ugly line. There we are. And you used a ruler because if you don't, you're gonna lose points, unfortunately. So I'm going to say in other words, we vertically stretch. So vertically stretch almost is spelled wrong. Oh, it is definitely spelled wrong. But vertically stretch implies multiplication. So we multiply the y values by 1/2. We could say this another way. So I'm just going to say we could say this another way because look at the green graph. Was the green graph stretched? No, it was made smaller. So we can say vertically compress. Now, compress in transformations might be better to think of as dividing. Ran out of space by a factor of 2, right? What did you do to the y values? Well, you divided all the y values by 2. Now, I'm not going to write anything here because I think it's important for you to ask yourself, how did these stretches affect the domain and range? Now, how did these? It actually has to do with this mapping notation, right? So if you want, you can press pause and think about that, try to take a guess, and then I will provide my input. All right, how did these stretches affect the domain and range? Well, from the mapping notation, since domain is a description of what are the possible x values, what we see is that the x values really remained unchanged. So the domain is unchanged when a is 2 and 1/2. However, the y values in both instances were changed, right? So this doesn't affect the domain, definitely affects the range. Okay, now let's go on to the next one. We are going to horizontally stretch. Oh, this should be fun. All right, before I get on there, I just want to revisit, go all the way up here and make sure I read this carefully here, because this is a little bit tricky. Anything with a horizontal in transformations really needs to pay attention. And when I say tricky, I've been doing this for a few years now, and horizontal transformations are still tricky. I need to be a little bit more careful. Y is equal to f, open brackets, b of x. This is a horizontal stretch about the y-axis by a factor of 1 over b. So those are the words that go along with it. Here, the transformation in point notation, I like point notation, it really helps me understand, xy becomes point x divided by y, x divided by b, comma, y. So in other words, it affects the x here. How? We're not going to multiply it, we're actually going to divide it by b. So I feel better now. Let me go down to my notes here. I am ready. I'm going to pick the low-hanging fruit here. We got y is equal to a, open brackets, f of b of x. Now here we're talking about this b, the number in front of the x is 2, so b is equal to 2. Now write this in words. This is a challenge. Press pause, look up to the previous definition and come back. Hope you tried that. It's fairly tough. Since b is equal to 2, we say that we horizontally stretch this by a factor of 1 over b, or a factor of a half. We can also say that we horizontally compress by a factor of 2. I forgot the word by a factor here, and that's important. So really, we have point x, y. And how does this change the point? These points become x over 2, comma, y. In other words, we're going to be dividing by the x by 2, which would be a compression of 2. Some people might say, well, we're really multiplying the x value by a half, which is also true. So depending on how you want to look at it. Regardless, now we're going to mess around with the x, right? So here, this is negative 2, 3. If we stretch it by a factor of half, it becomes negative 1, 3. This is 0, 0. 2, 1 gets compressed, and it becomes 1, 1. 4, 1 becomes 4, 2. So now I've compressed my points. That's what this graph looks like. Sorry, I said compressed because to me this is a compression, making smaller. However, it is still fair to say stretch. So I stretched it by a factor of a half, or I compressed it by a factor of 2. All right, let's move on to the next example. My next example here, now I'm going to criticize this. I have k of x, and I really shouldn't. I should have L of x. We must have different letters for each function. The only one where you can get away with it is by calling it y is equal to f 1/2 x. So I'm going to change colors here. I think I'm going to like pink or red. Okay, red. Here, what is the b value? Now, I'm just going to maybe write this a different way, and don't be fooled. So I could also write L of x is equal to f x divided by 2. In either of these cases, b is equal to 1/2. So, right, because multiplying by half is the same as dividing by 2. It's really easy to pick out b from here, much more difficult to pick out b here. Anyways, please press pause. Get ready to write those words. The words that go along with this is, we can say, stretched by a factor of 2. Wow. So point x, comma, y moves into, now this is going to be really quite ugly, x divided by 1/2, as if you follow the formula, right? But probably much easier to think of it as, what is x divided by a half? Simply 2x, right? So what's happening with the x values? Well, we're really stretching them by a factor of 2. So negative 2, 3 becomes, well, you multiply the x values by 2. Negative 2 times 2 is negative 4. 0, 0 remains 0, 0. Now, this kind of looks clumsy, so I'm just going to maybe see where my original point, was my original point. Remember, I'm working off my original graph. My original point was 2, 1. So this actually gets transformed to become 4, 1. And the point at 4, 1 actually gets transformed to become at 8, 1. So I'm going to try, now please use a straight line here. There we are. There we are. There. You used a ruler. Yours looks so much nicer than mine. All right. Anyways, this red graph, I hope the words match up. We're stretching it horizontally by a factor of 2. So again, how did this affect the domain and range? Well, really, the answer is in the point notation here and here. The range is unaffected. The y's stayed the same. We can see that on the graph and the point notation. However, the x's were changed. All right, allow me to explain this question. So this question says if f of x contains the following points, perhaps add an s there, 1, 2, 3, 5, 6, 1. We need to identify the image points on the following transform functions. So here, now this is a very tough question, right? We're throwing everything in the kitchen sink at you here. But keep in mind that if we have if we have a function y is equal to f of x, and we transform that into some y is equal to a f of b of x. Now, here I had point x comma y. Now, at point x comma y, what did it become? Well, what did the a do? Well, when a was negative, we multiplied it by -1. When a was, for example, 2, we multiplied the y value by -1. So what does a really do? A just simply multiplies the y value, right? However, if a is -2, we have to multiply it by -1, then multiply it by 2. So here, what did the b do? The b is really divides x. So that's going to be important, right? We're going to be taking a look at combining 2 transformations tomorrow, perhaps. I'm just saying now, let's get to the question. If I have point 1 comma 2, if I have point 3 comma 5 on a function, and if I have point 6 comma 1, these are all points on f of x. What do they become on these graphs as you transform them? So, and everything has the parent function y is equal to f of x. To me, the important thing to do is to identify what is a, what is b in each of these columns, and then transform your point. All right, I will leave that with you. Press pause, and shortly you're going to see what I've come up with. Not guaranteeing it's correct, but it's a pretty good effort. All right, so I've completed the table. The first thing that I did personally was I identified what are the values of a and b in each circumstance. And then I really tried to slow down my thinking. What does this mean? Okay. A is equal to, or y is equal to f of x divided by 2. A is equal to 1/2. Why? Simply because you could write it as y is equal to 1/2 f of x. Remember that divided by 2 is the same as multiplying by 1/2. Here, also, b is equal to 1/2, and that's easy to pick out. However, on an exam or a test, if somebody's in a particularly foul mood, they might give you, well, transform y is equal, or transform into y is equal to f, x divided by 2. Now it's really up to you to decipher that dividing x by 2 is the same as multiplying it by 1/2. I wish you all the luck. If you have any questions, please ask.